Have you ever wondered how your electric toothbrush or the fan in your computer works? You see, at the heart of these devices, there's a nifty little thing called a DC motor. Quite fascinating, isn't it? We're surrounded by these motors, yet many of us aren't aware of their existence. They're in our cars, our appliances, even our toys. Indeed, they're an integral part of our daily lives, silently doing their job. Every single one of these devices operates on the principle of a DC motor. A DC motor might seem complex, but it's composed of a few basic parts. Let's break it down. First, we have the stator. This stationary component serves as the framework, housing the magnetic field that drives the motor. Next, we find the rotor or the armature. This part spins, creating the motion we need. It's where the magic of electromagnetism happens, turning electrical energy into mechanical energy. Then there's the commutator. Think of it as the director of the show. It switches the direction of current, ensuring that the rotor spins in the right direction. Finally, we have the brushes. They may seem small and insignificant, but they play a crucial role. They deliver power to the commutator, allowing the current to flow. So, we have the stator, the rotor, the commutator, and the brushes. Each part playing its role, each part essential. These parts work together in harmony to make a DC motor run. So, how does a DC motor turn electrical energy into mechanical energy? Let's delve into the magic behind the motion, shall we? First, let's understand the principle of electromagnetic induction. It's a fundamental concept in which a change in the magnetic field within a coil of wire induces a voltage in the wire. In simple terms, it's the reason why we can convert electrical energy to mechanical energy and vice versa. Now let's talk about the magnetic field. In a DC motor, the magnetic field is produced by the magnets inside the motor. These aren't your everyday fridge magnets, but high-powered ones that create a strong magnetic field. This field is key to the operation of the motor. Here's how the magic happens. When we apply a direct current to the coil of wire within the motor, an electromagnetic force is generated. This force interacts with the magnetic field produced by the magnets. The interaction between these two forces generates a torque or turning force, causing the coil, and hence the motor shaft, to spin. But wait, there's more. The direction of the spin isn't random. It's determined by something known as the right-hand rule. If you point your thumb in the direction of the current and curl your fingers will point in the direction of the magnetic field. The palm of your hand then shows the direction of the force on the coil. One more thing to note is the commutator. It's a clever little device that reverses the direction of the current every half turn. This ensures that the torque always acts in the same direction, keeping the motor spinning smoothly. So, to sum it up, a DC motor works by using the principle of electromagnetic induction. A current-carrying coil in a magnetic field experiences a torque that causes it to spin. The direction of the spin is controlled by the right-hand rule, and the commutator ensures smooth, continuous rotation. And that's how a DC motor spins, converting electrical energy into mechanical energy. Quite a fascinating spectacle of science, isn't it? Let's take a moment to appreciate the genius behind the DC motor. This remarkable creation is a fascinating blend of simple components and complex physics, working together in perfect harmony to bring about motion. In the heart of this motor, we have the basic elements: the stator, the rotor, and the commutator. The stator is the stationary part, creating a permanent magnetic field. The rotor, or armature, is the moving part, where the magic really happens. It's here that electrical energy transforms into mechanical energy, giving us the motion we desire. Then we have the commutator, the unsung hero of the DC motor. This clever component ensures the current direction within the rotor always aligns with the magnetic field, keeping the motor spinning in the right direction. But what's truly remarkable is how these components work together. When an electric current passes through the armature, it creates a temporary magnetic field. This temporary field interacts with the permanent field from the stator, generating a force that causes the rotor to spin. This is the principle of operation in a nutshell. The reason why your toy car zips across the room, or why your electric fan keeps you cool on a hot summer's day. So next time you switch on your electric toothbrush, remember the marvel of engineering that makes it all possible: the DC motor.